Welcome to the channel, everyone. Today we're creating an object spawning system. We're going to use this system as an example of solid principles and advanced C# techniques, including generics, events, interfaces, and abstract classes, plus we'll use the factory and strategy patterns. Even though this is part of our 3D platform series, this is applicable to any Unity project. No matter your programming level, I hope this video will give you a few unique insights into architecting game systems. Let's get into it. Let's start by creating a few prefabs that we can spawn with our upcoming system here that we're about to build. So I've got a couple models here that I pulled in from some of my Cinti assets. So you can use whatever you want as models. And what I'm going to do is take these existing prefab models and I'm going to parent them under just empty game objects. So I'll call one collectible coin and I'll call the other one collectible chest. So these are going to become the prefabs that we're going to be spawning with the spawn system. Down in our scripts folder, I'm just going to open up an existing script so that I can start defining a new class from there. It's just going to be an abstract class and we're going to call it entity. Let's move it into its own class. Now, this is going to be a mono behavior because it's going to live on a game object that's going to be populated in the world. And we can have all kinds of entities. An entity could be an enemy. It could even be a player. For now, we're just going to worry about collectibles though. Now, it doesn't have to do anything yet. We just need a reference to it so that we can spawn it. But I am going to create another class called SpawnEffects so that it actually does something when it spawns. So let's write that really quick. Basically, I think I just want it to do a little pop and spawn an effect and play a sound. So let's get a reference to some VFX. Let's set a duration for how long the effect should be. And all I'm going to do in start, let's transform its local scale to 0. And then we're going to use doTween. Over the animation duration, we're going to move it back to a scale of 1, and then we're going to spawn our VFX, and then we're going to play whatever sound is been configured on our audio source. Let's put a require component in here just so it automatically adds the component for us when we put this onto our collectible. And let's jump back over to the editor, recompile our scripts, and let's get these set up on our prefabs here. So I'm just going to collapse them, and I'm going to add the component here to both of them at the same time. So we got our collectible, does nothing yet. Now let's also add our spawn effects. I'm just going to move audio source to the bottom. So we need to find a VFX. Now there's a link to a bunch of free effects in the description. I've already got one in mind here that shoots out these sparks. And so I'm going to lock the inspector and drag that in. And there's also a link to some free audio sound effects in the description. And I've already found one here. Now, the ones that are linked there aren't named very well, but the one that has a little pop sound, let me just find it here. It was number 21. Does a little pop. So I'm going to drag that one in for both of them. With that done, we can unlock the inspector. And we need to turn both of these into prefabs. I'm just going to drag them into the prefab folder. Now, just before we do a little test, I'm going to make sure everything's saved up. And I'm also going to make sure that everything is reset to 0 on the transforms inside of my two different collectibles here, just so there's no surprises. So I get them set back where I want them so I can see. And yeah, they definitely spawn the way I expect. Let's play that back in slow motion just to, yeah, there we go. So, you know, that looks kind of neat. I think we'll go with that for now. Let's remove those two from the scene. Let's create a new empty game object. This is going to be our Collectable Spawn Manager, and we're going to start getting into the design. Experienced developers often respond with, "It depends," when asked, what is the best solution for a problem? Because of the complex nature of most game dev problems, there often isn't a one-size-fits-all solution. Solid principles are the same. They serve as guidance rather than hard rules. Each principle offers a viewpoint to tackle design challenges without guaranteeing an optimal solution for every scenario. Knowing when to apply, bend, or even bypass these principles is an art form. Seeing these concepts explained with a practical example, I think, will be very helpful. And before we start coding, let's discuss the design of our system. Today, we're spawning collectibles, but we want to build our spawning system so that it doesn't care what it will spawn or where it's going to spawn them. Using class diagrams is new to this channel, so if you find this kind of visual representation of system architecture helpful, let me know by clicking that like button. Now, the main thing to notice in this diagram is that there are no circular dependencies. Everything flows in a tree-like structure upwards. And you'll notice there are several points where there's an abstraction, either an abstract class or an interface, and we'll get into all of that as well. So we're going to code this from the bottom up, and we'll keep revisiting this diagram and talk about it as we build each part. Let's begin with EntityData, a simple class that stores data for an entity we wish to spawn. So here we can specify properties like the prefab for the entity. Now, right now, we only care about the visual details of this specific collectible so that we can see that it's spawning. But as the game develops, we can also specify other details about the item here, such as a sprite if you wanted to make this spawnable item something the player can add to their inventory. This separation of data from our actual logic of spawning will simplify future modifications. Because this system is going to be completely independent from everything else in our game and could be reusable really in any game, let's create a new folder for this. And I'll start a new script in here for our abstract class EntityData. So any kind of data representing an object that we want to spawn can inherit from EntityData. So EntityData, really, we can just remove all this stuff. All we really care about this is pretty much everything we want to spawn has to have a prefab. So let's put that in the abstract class. And then let's make a concrete implementation of that called collectible data. Collectible data can have data that's specific to collectibles. For now, I'll just put a score property in there. We'll put this into its own class. I'll just add a little comment here for future reference. And we need to add an attribute here so that we can create instances of these in the editor, which requires using Unity Engine. Let's go back into Unity and let's try it out. So from a previous video, we already made a scriptable objects folder. Let's go into create platformer and we'll create our new collectible data here. I'm just going to call this one coin. Now we've already made our coin prefab, our collectible coin. So let's drag that in there. I'll just give it a default score of say 10. While we're here, we might as well make one for the chest as well. So just drag the prefab in there and I'll give it a default value of say 50. Let's jump back over to our diagram because we're done with the data now. Let's talk about ISpawnPointStrategy. So this interface is going to let us implement different strategies for spawning spawn points. So one of them is going to be linear spawn point strategy. So that'll just take every spawn point we've defined in an array and go through them one by one. The random spawn point strategy will pick them at random, just like it sounds. So the benefit of using the strategy programming pattern is the spawner itself doesn't need to know how the strategy works. All it cares about is that the strategy returns a position where to spawn this particular entity. All right, the interface for this is actually very straightforward. It only has one method. So let's declare a public interface ISpawnPointStrategy. It's just going to return a transform. We'll call it next spawn point. So no matter what the strategy is, that's the method that it has to implement. So let's start with the concrete implementation of the linear one because that's probably a little bit simpler. So we'll make a public class linear spawn point strategy implements the ISpawnPointStrategy interface. And we're going to just set an index and we're going to pass in through the constructor a list of spawn points that it can choose from. And so in next spawn point, simply return the next one in the array. Let's increment our index such that when it reaches the end, it starts from the beginning again. So it could just, technically, it could just spawn forever. All right, let's move that into its own class and we'll come back and we'll build the random one. So again, this is going to implement the ISpawnPointStrategy interface. Only has one method. The main difference between linear and random is that the linear strategy is never going to try to use the same spawn point more than once because it's just going over each one. The random one, we got to make sure, potentially, that we don't want it choosing the same spawn point over and over again. So let's make a list. We'll just hold all the unused spawn points. When we call the constructor, we'll populate that list. And then when we've run out of unused spawn points, we'll just repopulate the list again. Beyond that, we're just going to select one from the unused list. We're going to pass it back and remove it from that unused list. So that'll keep taking the unused list down to 0. We'll always get a fresh spawn point. Okay, that's it for our strategies. Let's move that into its own class and let's go look at the diagram again. So our EntityFactory is going to implement the EntityFactory generic interface. And basically, this also has one responsibility. All the factory is responsible for is to leverage the data to create actual instances of entities. So this class, EntityFactory, exemplifies extensibility. In the future, we could add logic to set other properties on the instance prefab, such as health, speed, even AI behaviors. So all of these could be defined in EntityData and implemented in our EntityFactory without affecting spawning mechanics at all. Let's start by defining our generic interface. So we're just going to call it EntityFactory of type T, where T is an entity. So we're going to return the entity after we've used the create method. Now, create expects one parameter, and that is the spawn point. That's it. Super simple. Now let's implement a concrete version of that interface. It's going to be super generic right now and very simple, but if we need a more complicated factory in the future, we can just implement the interface. So let's fill out our method here. We're going to store all the entity data, and we'll pass that in through the constructor. In the create method, let's just choose one of the entity datas. We'll instantiate the prefab at the spawn point, and then we're going to return the component of type T, whatever the T was. Okay, that's it for our factory pattern. Let's move our concrete entity factory into its own class, and let's take another look at our diagram. So now it's time to implement our spawner. So our spawner is also going to be a generic class of any type. Our EntitySpawner class ties everything together, uses the factory to create entities and the strategy to decide their placement. Let's define a new class, EntitySpawner of type T, where T is of type entity. Let's move that into its own class. So as you saw from the diagram and what we've built so far, the spawner is going to have two dependencies. So we'll add references to those interfaces here, and we're going to pass them in through the constructor. Now the spawner only has one job, and that is to spawn whatever type T is. So it will return T, which we can do something with it if we need to from the caller side. So all it's going to do is return EntityFactory.create and then pass in SpawnPointStrategy next spawn point. That's it. Super simple. Finally, we have the abstract class EntitySpawManager and its concrete implementation, the Collectable Spawn Manager. Now, the primary purpose of the Collectable Spawn Manager is so that we can configure the spawner in the editor before it's instantiated. Okay, let's start by defining our abstract class, EntitySpawManager. So it's going to be a mono behavior because we're going to put it on a game object. And we're going to make some fields available to classes that inherit from this. So one of those is going to be the ability to define which strategy we're going to use. So we're going to make an enum for that. And then we'll be able to choose it in the editor. We'll just set it to default to linear. Also, any spawner is going to need a reference to spawn points. I'm just going to move this into its own class before it gets any longer than this. So we need to define a few more things. We're going to want to override the awake method. So let's make it a protected virtual method. And in here, we'll just have a switch that's going to set the spawn point strategy based on the selection in the editor. All concrete implementations are going to have to implement the spawn method. And I'm going to restructure our switch statement here to be a switch expression so it's a little bit easier to read. Okay, on to our concrete implementation. So this is going to be called Collectable Spawn Manager. Inherits from EntitySpawManager. We can just control period. We'll move it into its own class. We'll implement its default methods. So Collectable Spawn Manager is going to need reference to collectible data that we're going to populate in the editor. I'm going to put a spawn interval in here as well, and we'll get to that in a second. So let's deal with our awake method. We're going to override it, and we're going to call the base method still, so don't forget about that. Now in Awake, we're going to want to instantiate our spawner. Let's set a reference for that. So spawner is just going to be a new entity spawner of type collectible, and we're going to pass in a new entity factory of type collectible that receives the collectible data, and we're going to pass in whatever strategy's been chosen in the editor. Just got to update my collectible data to be an array there. Okay, now in spawn method, all we have to do is tell the spawner to spawn. So let's change that to expression body method. Now there's a couple things to think about. When do we want to call the spawner and tell it to spawn something? Well, I think the easiest thing to do is to make use of our timer class that we introduced in the last video. So if you recall, all timers have events that we can subscribe to. Whenever our countdown timer is finished, we can simply spawn another entity, start the timer over again. So let's just subscribe to that event and do exactly that. We'll call our spawn method, restart the timer. Now the way that it's set up right now, it would just run forever. Why don't we introduce a counter? And then in our method that we're passing to the event, we can say, if it's greater than our collectible data's length, let's just stop. That's it. And increment our counter there. Now in update, with all timers, we have to make it tick with time.delta time. And we need to start the timer at least once. So let's do that in the start method. I'll just add another expression body method here that just starts the timer. And now let's add that class to our game object that we've got here. So now we just have to populate some stuff. You can see we can choose between linear and random. And let's see here. Let's grab our coin. We'll drag that in as our one data for some testing. And we need to create some spawn points. So I think for now I'm just going to make them children of the Collectable Spawn Manager, but really they could go anywhere. Let's slide this. So I think I'll just put them in a row up here so it's easy to see right in front of the player. I'm just going to add some gizmos here so I can visualize this a little better. I'll just give them some little yellow diamonds. Okay, then we just need to drag all these references into our Collectible Spawn Manager. There we go. All right, let's press play and have a look. Okay, spawned one. Okay, we spawned one, and that's because the timer is only running up to the collectible data's length. How about if we run it until we've crossed the entire length of our spawn points array? That would be better. And also I realize that I'm counting up in the if statement, so we don't need to be counting up down below there as well. That was Copilot getting ahead of me. Let's try this again. So here's our linear spawn. Looks great. 1, 2, 3, 4. Exactly what we expected. Why don't we try it with a random strategy? There we go. 2, 3, 4, 1. Let's do it one more time. Okay, great. It's doing exactly what we expect. I'm pretty happy with that. All right, well, that's looking pretty good. So I hope this tutorial not only helps you understand how to create a spawning system in Unity, but also demonstrates the importance of designing your code with future expansion in mind. By following solid principles and using patterns like the strategy pattern, we can create code that's both robust and easy to maintain and expand. So let's do a quick recap over the design. This solution adheres to solid principles in the following ways. Single responsibility principle. Each class and interface has a single responsibility, such as creating entities, selecting spawn points, or managing the spawn process. Open-close principle. The system is open to extension, but closed for modification. For example, to change the spawning strategy or create different types of entities, you don't need to modify existing classes. You just create new ones that implement the relevant interfaces or extend from base classes. Liskov substitution, LSP. The use of interfaces allows any class that implements the interface to be used interchangeably. For example, any class implementing the ISpawnPointStrategy can be used as the strategy for choosing spawn points. Interface segregation principle. Components are not forced to depend on interfaces they do not use. For example, the EntitySpawner class doesn't need to know how the spawn point is selected. It only needs an object that implements ISpawnPointStrategy. Dependency inversion means that your components depend on abstractions. For example, EntitySpawner doesn't depend on a specific factory or a specific strategy implementation and doesn't instantiate anything new in regards to that. It just depends on interfaces, and that means you can supply it with any factory or spawn point strategy that you want. And in our case, we're doing it through the constructor. So this makes our system more flexible, as specific implementations of these dependencies can easily be swapped out without having to change the EntitySpawner class at all. So that wraps up our tutorial on building a flexible spawning system in Unity. As you can see, this approach provides a powerful and flexible way for you to control entity spawning. And we're going to make more use of this in the next video, where we're going to implement the observer pattern to actually collect these things and start getting a score and having different things happen. Thanks for watching, and I'll see you in the comments below.